At the end of a tree-lined road in northern Kansas City, you'll find the National Weather Service's Aviation Weather Center. The history of aviation weather and the Aviation Weather Center, or AWC, began in 1961 when the U.S. Air Force issued the first official forecast for clear air turbulence. One of aviation weather's defining moments occurred in 1977 with the crash of Southern Airlines 242 in New Hope, Georgia. Unfortunately, there were 72 fatalities when the airplane encountered developing thunderstorms and crashed. As a result of this accident, the National Transportation Safety Board, NTSB, put out a recommendation for procedures for the timely dissemination of all available severe weather information by controllers. As a ripple effect from the Georgia aviation disaster, the National Severe Storms Forecast Center established the Convective SIGMET unit in 1978. Additionally, the National Weather Service established embedded aviation meteorologists at 13 of the nation's FAA air route traffic control centers. By 1981, the National Weather Service staffed aviation meteorologists inside all 21 air route traffic control centers. This is a partnership with the FAA that still exists today, known as the NWS Center Weather Service Unit, or CWSU program. In addition to the established CWSUs, the original Convective SIGMET unit was named the National Aviation Weather Advisory Unit, then was renamed again in 1995 to the Aviation Weather Center we know today. Finally, the Aviation Weather Center found its new home in the Kansas City Northland in 1999. Today, the team at the Aviation Weather Center sits within the executive branch under the Department of Commerce of the U.S. government as part of NOAA's National Weather Service. Why commerce? In addition to protecting lives and property, aviation forecasts help air traffic planners make air traffic management decisions like ground delay programs or planned routes, all with a large economic impact. The National Weather Service as a whole is divided into one national headquarters, 6 regional headquarters, 122 local weather forecast offices, 13 river forecast centers, 1 national water center, 21 center weather service units, and the National Centers for Environmental Prediction. National Centers for Environmental Prediction, or NCEP, is a collective of several national centers such as the Aviation Weather Center, the Storm Prediction Center, the National Hurricane Center, and the Space Weather Prediction Center. What makes a national center different from a standard National Weather Service weather forecast office? Well, not only do they have a much larger area of responsibility, the majority of these centers also have an international responsibility. Let's take a look a little closer at the aviation challenges that make the Aviation Weather Center vitally important to the nation's airspace. It may not be much of a surprise that as much as 67% of the delay in the National Airspace System can be attributed to weather. A 2020 study equated this to an economic loss in the U.S. of nearly $23 billion annually. Additionally, the Aviation Weather Center's information is here to serve general aviators who are private pilots and non-scheduled carriers, also an important part of the aviation community. The number of general aviation fatalities related to weather rival those caused by lightning, tornadoes, tropical storm winds, hail, cold, winter storms, and high winds combined. According to the NTSB, around 23% of general aviation accidents that occur annually are weather-related. If you look at just fatal accidents, that number rises to 27% on average each year. Comparing weather challenges across all accidents and fatal accidents, NTSB data confirms that low ceiling and low visibility accidents are almost always fatal. Instrument meteorological conditions, or IMC, is particularly dangerous for pilots with Visual Flight Rules Rating, or VFR. They haven't had the required training or experience to use instruments that can assist in these tricky situations, and these situations can also become dangerous very quickly. For these reasons, the information provided by the National Weather Service's aviation program is critical to protecting lives in the national airspace, while also contributing to flight efficiency, enhancing the economy. In fact, it's the mission of the Aviation Weather Center to deliver consistent, timely, and accurate weather information for the world airspace system. You heard that right, world! The Aviation Weather Center is one of 2 offices in the world designated as a World Area Forecast Center, providing global aviation weather forecasts for international interests. The other office is the UK Met Office, and we partner closely with our colleagues across the pond to provide data and forecasts. The Aviation Weather Center is comprised of 3 branches across 2 different locations. The staff of around 80 highly skilled people are dedicated to working with customers and partners to enhance safe and efficient flight. Personnel include forecasters, researchers, developers, IT staff, administrative and business support staff, managers, and a NOAA Corps officer. Most of these folks are stationed on-site in Kansas City. The operations branch is responsible for routine, non-advisory forecasts, aviation weather advisories, and aviation weather warnings. They maintain a continuous weather watch stance 24 hours a day, 7 days a week, 365 days a year. The aviation support branch is responsible for our flagship dissemination website, aviationweather.gov, as well as data architecture, aviation weather research to operations, and much, much more. And the final branch of AWC is the National Aviation Meteorologists. This is the only branch that isn't located in Kansas City and instead outside of Washington, D.C., along with our FAA partners at the Command Center. Here they provide direct decision support services to our partners who are then taking that information to make traffic management initiative planning and implementation decisions. Additionally, the National Aviation Meteorologist assists with the National Airspace post-event reviews, debriefings, and strategic planning, all a piece of striving for continuous improvement. Along with the Aviation Weather Center, the National Weather Service Aviation Weather Program consists of terminal aerodrome forecasts produced by the 122 local weather forecast offices. There are center weather service units embedded in each of the nation's 21 FAA air route traffic control centers. NOAA also hosts 2 volcanic ash advisory centers. Now let's look a little closer at how the Aviation Weather Center conveys critical information to pilots. A SIGMET, or Significant Meteorological Information Product, is a weather warning for aircraft in flight. Think of it as the pilot version of the weather warnings produced on the ground by National Weather Service forecast offices. Aviation meteorologists add an additional dimension to warnings by identifying specific layers where that hazard is located. It adds a layer of complexity, which is designed to help pilots and air traffic controllers determine if a hazard layer can be circumnavigated. The Aviation Weather Center issues SIGMETs for severe turbulence, severe icing, volcanic ash, widespread sand or dust storms, thunderstorms, and tropical cyclones. A SIGMET can be for convective or non-convective-based weather conditions. Non-convective SIGMETs are valid for 4 hours and issued as needed. Convective SIGMETs are valid for 2 hours, issued hourly by 55 minutes after the hour in domestic airspace. Tropical cyclone SIGMETs are valid for 6 hours, issued in conjunction with tropical cyclone advisories, and occur over international waters where the U.S. has SIGMET responsibilities. With such a large area of responsibility and active thunderstorms, the volume of warnings issued by the Aviation Weather Center is quite staggering. On average, 44,100 convective SIGMETs are issued per year. The busiest month is typically July. An AIRMET, or Airmen's Meteorological Information, is a weather advisory that tells pilots where to expect moderate turbulence, moderate icing, low ceilings and low visibility, and/or strong surface winds. Graphical AIRMET products, or G-AIRMETs, are for hazardous weather in the domestic airspace. They're issued 4 times per day at 3Z, 9Z, 15Z, and 21Z. They are intended to describe a snapshot of the weather at that time, every 3 hours out to 12 hours. Lastly, the Aviation Weather Center produces routine non-advisory forecasts. This includes the low-level significant weather chart for less than 24,000 feet and the automated significant weather or SIGWeather charts that are a part of the World Area Forecast System. Another non-advisory product is the Traffic Flow Management Unit Convective Forecast, or TCF forecast, which is a 4, 6, and 8-hour convective forecast. This is one of the most highly collaborated forecasts in the entire National Weather Service. The Aviation Weather Center leads a chat discussion about every 2 hours to discuss thunderstorm coverage maps in collaboration with meteorologists across the entire industry, including airline meteorologists and our Canadian colleagues. It is used by the FAA for air traffic planning purposes to help prevent monetary losses from cancellations and diversions. The TCF is automated from November 1st through April 30th, when thunderstorm season isn't quite as active. You can find all the products we discussed and more on the Aviation Weather Center website, aviationweather.gov. This website contains the current warnings and advisories for aviation weather, as well as news, interactive maps, and detailed information about each product issued by the Aviation Weather Center. You can also use the site seamlessly on mobile phones and get the same experience regardless of what device you are viewing it on. Thank you for taking some time to learn about the Aviation Weather Center, informing flight with weather wisdom. If you have any questions or want to talk more about the work performed at the Aviation Weather Center, please contact me, the Aviation Weather Center's Warning Coordination Meteorologist, Jennifer Struzes, using the information on the screen.